360 Fiddler AI. Okay, Suresh, I'll start with it now.
Okay, perfect.
Hi, everyone. Welcome to WeeklyWed. WeeklyWed is a speaker series in AI, AV, IoT, where students of Sudha from Stanford, Barcelona, Spain students of different learnings, they come together to learn more about AI, AV, and IoT. We are having generative AI, and these are exciting times to be learning, to be unlearning, and to be relearning. Welcome, everybody. Welcome to WeeklyWed. I am Yashaswini Vishwanath. I'm logging from Bangalore, India, and you can call me Yash. I have hosted WeeklyWed for quite some time, and WeeklyWed is my passion. I like to come here every Wednesday, interview people, talk to them, ask a lot of questions, and bring in the fresh creme de la creme here to all the community here. Today, I would like to tell about myself. I'm an AI researcher. I'm an AI engineer. I have over 12 plus years of experience here in the startup capital of India, Bangalore, and it's called the Silicon Valley of India. Today is a very important day given that responsible AI is the talk of the town. Everybody was wondering, the AI thesis, and everybody were wondering what AI could do. But now, with generative AI, we see that AI is moving at a very fast pace. Responsible AI is not an option, it is mandatory. It is mandatory for everybody building AI to understand what is responsible AI and bring it for their products. Now, I will quickly share my screen. First, I'll be explaining what is explainable AI. Then I have a short worksheet that I will run with everybody here in the Zoom room. And anybody from LinkedIn, do chime in and we can have an interactive session. Yeah, there we go. Hope everybody is able to see the screen now. So here we see an AI, a robot, trying to teach a set of humans some infographic. What does it say? Is it that the humans do not know what the AI is trying to say? Is it that the AI has come up with it on its own? Why do we need explainable AI? That's a question we should be first answering. Before that, I would like to dwell a bit deeper, deep dive into explainable AI, the intricacies of explainable AI. This is a classic example of when you have a recommendation system, say the Netflix recommendation system, or the YouTube recommendation system, the Amazon recommendation system. It takes the user history and it gives recommendation. 2 weeks back, we had Kenchikwo from Lagos who explained what is content-based, what is collaborative, and what is market basket analysis. Here, when we take user history and give a recommendation, we are trying to personalize. Personalizing, searching, ranking, all are different arms of recommendation. Here we see that movie 1 was recommended and movie 2 was not recommended. Now the question the user asks is, why is that movie 2 was not recommended? And why is that movie 1 was recommended? Up until some time, the AI systems and the decisions the AI systems take were the gold standard. But now we need an explanation. I will take this example, which will really touch why we need it. Here, Sam applies for a mortgage. Sam's application is inputted into an AI. AI estimates Sam's probability of defaulting. Sam's mortgage application is rejected. See, in this case, Sam does not get his loan. This is a big decision. The criticality of the decision is high, and the extent of explainability required is also high. Now, when we see who is interested in the explanations, Sam, who applied, the other people who got the loan mortgage, yes, the regulatory bodies, and the general public. This is a classic finance example where explainable AI comes into picture. Here, the creditworthiness of a person has been calculated by using previous loan overdue, income, employed, term length, credit score, number of children, previous loan count, annuity, and macro effects such as unemployment rate, inflation rate, GDP growth. Here we see certain highlighted rays. Those are the features which are trying to influence the credit worthy. Okay. Now we saw about finance example. Here is explainable AI only for finance, insurance, banking? Who else needs it? Transportation needs it. Security, legal, medicine, military. This is by DARPA, and they say a user can ask, why did you do that? Why not something else? When do you succeed? When do you fail? When can I trust you? How do I correct an error? These are the questions that a user can ask an explainable AI. What is explainable AI? It's a wing of responsible AI. We talk about compliance, ethical AI, secure AI, interpretable machine learning, human-centered machine learning, and responsible AI is the umbrella term where all of these come in. Now I have a question for the students here in the Zoom room. Is your AI ethical, transparent, and compliant?
We do not know.
Okay. Maybe by the end of the class, you'll be able to get some insights on how do you decide whether it is ethical, transparent, and compliant, which particular product requires explainability, and what is the extent of explainability required. Thank you, Suresh.
Yeah, no problem.
We know about GDPR law, and GDPR in turn has fairness, privacy, explainability, transparency, and we see we see that these are the talk of the town. Everybody wants to defend themselves. They want to defend themselves that what they are doing is responsible, it's trustable. Explainable AI can be considered the collection of processes that help the developer and the users understand and interpret the results. So, the word here that is very important is interpret. We have results from the AI, and these results are to be interpreted. Why did it take the decision like this? We see here for the same loan application, we see a regular black box and we say no output. And we see a transparent AI. It says no because age is less than 25. Salary is less than $1,000. Unpaid bills is greater than 4. It's trying to tell us, it's trying to explain itself why the credit was not approved. In a machine learning system, we have deep neural networks which have the hidden layer, the output layer, and multiple layers within. We say that neural networks are a black box. The way these neural networks function is that the various layers, they keep learning features. They become stronger and stronger from the hidden layer till the output layer. So this is the cat. It has fur, whiskers, claws. This neural network is learning and it is explaining. We see here, it's an image data. In the finance example that we saw, it's numerical data. Here we are trying to see explainable AI for different kind of data modalities. I would like to highlight here that in order to bring in an explainable AI into our models, we need to make the model explainable, plus we need to have an explanation interface. This explanation interface can be again image, text, audio, video, or it could be a cell in an Excel sheet. But the interface is something that has to be designed because the user interacts with it. When we talk about explanation interface, we remember human-computer interaction and how this explanation interface is extrapolating the human-computer interaction with new principles, strategies, and techniques to generate effective applications, explanations. And what is the psychology of an explanation? Is it summarizing? Is it extending? Or is it trying to use the current psychological theories and trying to come up with a computational theory? These are left to the developer who is trying to build the explainable model and the explanation interface. There are various reasons why we need to explain. Before I go to that, I would like to know if there are any questions that any of you have.
I'm good, Yash. Thank you.
Okay. The various reasons for explanation could be explain to justify, explain to control, explain to discover, explain to improve. You are trying different things here, and each of this has a different form of an interface and a different form of a model. The same model that can be used for justification may not work for improvement because the way it gives the explanation may not be applicable here. We should be in a position to design explainable models and explanation interface based on why is that we want to explain. Another important factor that I would like to bring in here is whom we are explaining. I'll tell about that in the coming slides. This is the white box local explanation. So here we are talking about the mortality risk score, where if in case there is a black box model, and if we have a white box model, it tells which feature is weighted and why. The mortality risk score is 4. Here we try to understand the model summarization, feature dependence, interaction effects. We can monitor the model using this. If there's a concept drift, if there's a data drift in the CI/CD pipeline, and we can have explanation embeddings. I have to say, SHAP values. What does SHAP mean? SHAP is a short form for shapely values. This comes from game theory and it's used for local explanations. So here we see we have a tree explainer, we have a model, and this tree explainer model will explain this black box model. What is the effect? What is the effect of having explainable AI? We can reduce the impact of model biasing. If we know that there is a bias involved, we can go fix it. Is it in the data set? Is it at source? Is it at the model level? Is it the algorithm? What is the bias? What is causing the bias? We can figure it out and fix it. Bias isn't good. It could be social bias, representation bias, temporal bias, cognitive biases, none of them. Explainable AI gives rise to responsibility and accountability. Here, the model developers, once they develop and deploy the model by itself will give the explanation. This is how they make an AI system responsible and accountable for the decision it takes. It gives the reason. It takes the accountability onto itself. The AI system takes the accountability onto itself. Governance. Governance is the key reason why corporations are pushing for explainable AI. Code confidence. Whenever a data scientist who builds a model and deploys it and then gets the explanation, he is clear how his code is working inside the model. This is from a data scientist perspective. And code compliance. This is also from the programmer perspective, where we know that the code is behaving the way it has to behave. The behavior of the code is what we call as code compliance here. This is a beautiful rainbow here. Uh, it says the different areas where AI can come in and explainable AI can come in. It could be AI assisted drug design, banking customer engagement, robo advisors. We have all heard about robo surgical doctors, I have to say, because I recently went to a hospital here and they had a very huge billboard with a lot of arms, robotic arms, and they had mentioned that their hospital is well versed in it. So robo advisors may give us the advice that we want for the problems that we have. Collections, that is the money collections, payment expect exceptions, fraud detection, insurance pricing, claims management, that's in the insurance segment, customer retention. By knowing explainable AI, there is a very high probability that if you know that somebody will churn or not churn, you can predict it and give the explanation why there could be a reason for that person to churn and try to prevent the churn. Here are the 5 key questions to answer when building explainable AI. Explain to whom. Who are the different stakeholders to whom we need to explain? Why we need to explain? List the objectives and reasons for explanation. How to explain. Explore the different methods of explanation. When to explain. Is it before, during, or after the model is built? What are the explanation techniques? Taxonomy of different techniques of explanation. We will dive deeper into this.
Yes.
So here we have local explanation, global explanation. What do we mean by local? The individual prediction is what is explained. When we have global explanation, the entire model is explained. We have model specific and model agnostic. I showed Shapely value, Shap tool. There is Lime tool also. These tools are extensively used in the industry. Model specific, integrated gradients, tree feature contribution. A tree structure is naturally explaining. That's why many of these models will have a tree classifier to explain why a particular decision was taken.
Okay.
This is a very important slide. Although we talk about the technology, the programming, the model building,
Right. Target audience.
here it depends on who is the target audience. Based on that, our explainable model and interface will change. Domain experts, users of the model. Why do we need for them? Because they want to trust the model itself and gain scientific knowledge. Users affected by model decisions. Understand the situation, verify fair decisions. As I mentioned, data scientists, developers, product owners, they need to ensure and improve product efficiency, research, and new functionalities. Managers and executive board members, they assess regulatory compliance, understand corporate AI applications,
Mhm.
regulatory entities and agencies. It's about audits and legislation. So this is what we were trying to see, the different stakeholders, the expert, the subject matter expert, the, the commander, this is a DARPA example, the policy maker. Yes. This is a very critical piece of a worksheet that I want to share with everybody here. It'll be very good if you can come on, if you can unmute and take some examples of AI that you have known, not necessarily worked on, but you have known. And we can see there are two axes here, the criticality of decision and the extent of explainability required.
Right.
So I would like to first take an example. My favorite is the marketing recommendation engine. So it's personalized. It comes here. The criticality of decision is low. The extent of explainability required is high. So if you tell your use case, I will try to map it to these 4 quadrants and say where it will come. It could be a use case that you have heard of, read in the news, or that's coming to your mind. It need not be necessarily what you have worked on.
So why is the autonomous car on the right side of where it has more explainability required, right? So, I
It's
mean, when
high.
it's high, hmm, criticality, yeah.
Criticality of decision is high.
This is explaining to somebody in the car, or is it or the decisions it is taking, it needs to explain to somebody, or what is the, how do you interpret that? I didn't understand that.
There could be different AIs when we talk about autonomous cars because we have been
Hmm,
uh, reading about them. We have written research papers about them, and you have seen autonomous cars
yeah.
there go around in your community. There are multiple modules that the umbrella autonomous car can
Right.
have. The way this quadrant is done, so we see here driver assistance is here.
Mm-hmm.
Um, by autonomous
Yeah,
car, I mean the
like
when they have
Waymo, right?
the passenger, they have to stop, and property, they have to stop. Maybe that is the critical decision that they're trying to take.
Yeah, but who is it trying to explain to? I'm not sure I understand this quadrant though properly, but that's fraud detection. I understand crime predict. That's okay. Yeah,
I have the answer for that.
yeah.
Uh, Sudha had shown once. Tesla Tesla has a complete analysis, AI analysis of every incident.
Hmm.
The Tesla car goes and hits a footpath. So it's an incident.
Oh,
And
wow. Hmm.
the AI will give the complete explanation as to why it happened.
Right.
This is somewhat similar to the black box in the airplane.
Hmm.
And in case something were to happen to the airplane, the black
Right.
box is retrieved and the recording is seen as to why, which was the system which actually failed.
Hmm.
I
I see.
have to say, these concepts have always been, and it is not something that is specific to AI. We have taken concepts from the other domains and trying to bring it into AI. Even airplanes, they had to explain themselves in case of an incident.
Hmm. Perfect, Yash.
Okay. Yes. This is from Fiddler AI. Where does explainability come? Does explainability come at the start, at the middle, or at the end when we are doing the monitoring and we have done the deployment? Explainable AI is at every step. Explainable AI should be ingrained into every step. Only then we will be able to have a successful explainable model and an explanation interface.
Right.
Here we see model debugging, model visualization, that is a training, model evaluation, compliance testing, QA, deployment, model launch sign off, model release management. Here in predict, we see explainable decisions, API support, A/B test, model comparison, cohort analysis, monitor, performance monitoring, fairness monitoring, model diagnostics, root cause analysis, and the feedback goes. This is how an explainable AI is built through the pipeline. Here is a cheat sheet. Cheat sheets are always good when we want to try to implement something. Explaining a model's decision. Yes, I want to explain. Is the model interpretable by design? Yes, like say logistic regression, KNN, linear models. No, it's not interpretable. Then I need a method that works for all the models. Yes, so I go for model agnostic, Lime, SHAP, perturbation. No, it's okay. I can have different models for different. Then it's gradient saliency, integrated gradients, attention. In case the specific example from the data set that could uncover the insights about the model, we can go for counterfactual, influence functions, adversarial. You may hear a lot of terms in the slide which you do not know, but hold on. This is just the start of explainable AI. And when you go back, when you study the research papers, you can see these words, and then you'll remember, yes, explainable AI also use these concepts. These are not concepts that have been innovated, invented, created for explainable AI. It's there in all the AI systems, algorithms, models. We have taking those elements and trying to see how we can use that and bring out explainability for the AI systems. So that's where I stop my share. And any doubts, any questions, I can take them.
Good slides, Yash. Good work in gathering them and making it very presentable, very explainable. So that's good. Yeah.
Thank you, Suresh.
So this is built. Just one question I have. So you said you can interpret the image data too, or is it not possible? I'm not even sure if it's possible to do the image data explanation.
The neural network,
Yeah.
it will learn layer by layer, and it will have the activation function in between in
Mhm.
order to activate certain neurons. At this point in 2024, we have explainable AI even for image data, where it says, in this layer, I learned this feature. In this layer, I learned this feature.
Mm,
Available.
very nice.
Mhm. Okay. Thank you, everybody, for coming to WeeklyWed. Let's catch up next Wednesday at the same time. Thank you, everybody, for joining. Bye.
Thank you so much. Bye, Ananya.